While other nations are still debating the ethics of autonomous weapons, China has already built them, deployed them, and is now scaling them. What you are about to see is not a projection of what might happen by 2030. It is happening right now. China's largest military bionic robot is not a dog, and it is not humanoid. It is a mechanical yak, an enormous quadruped built to operate as a battlefield logistics carrier in environments where conventional vehicles cannot function. Presented publicly by China Central Television, the robotic yak dwarfs the smaller quadruped robots the world is more familiar with. Its commercial counterparts are less than half its size. It carries up to 160 kilograms of cargo and reaches speeds of 10 kilometers per hour across snow, desert, and Rocky Mountain terrain simultaneously. The machine is equipped with 12 sets of sensor modules that allow it to perceive its surrounding environment comprehensively, not just to avoid obstacles, but to gather tactical reconnaissance data while completing its logistics mission. It can jump, run, move diagonally, and execute tight turns. It was designed specifically for deployment in border territories and in the most inaccessible and weather-extreme operational zones, where resupplying human forces has historically required either helicopter exposure or unacceptable delay. In late 2022, Kestrel Defense released footage of a robot dog being dropped from a drone onto a rooftop. After the drone departs, the robot stands up, scans the landing area, and begins providing fire support with a mounted QBB-97 light machine gun, a weapon capable of firing 650 rounds per minute at an effective range of 400 meters, chambered in China's standard 5.8 AEM intermediate cartridge. The platform weighs around 15 kilograms, is controlled through a military tablet application, and features a 360-degree camera system for full situational awareness. The tactical implications of this specific capability are what caused analysts to pay close attention. The drone deployment system means a weapon platform can be inserted onto a rooftop or into a position behind enemy lines without requiring a helicopter, without requiring a soldier to make that insertion, and without the enemy having any practical way to anticipate where the platform will appear. Unveiled at Airshow China 2024, China's robotic companion platforms, four-legged drones weighing approximately 70 kilograms, were deployed alongside the PLA's 76th Group Army in live field exercises. CCTV footage showed these robots climbing hills, crossing rivers, mounting ladders, and maintaining pace with human soldiers across challenging terrain. They performed reconnaissance and coordination tasks simultaneously, relaying real-time data to operators while keeping up with the physical demands of the exercise. What the PLA exercise footage demonstrated specifically was seamless human-robot drone integration. Human soldiers, ground robots, and aerial drones operating in coordinated formation as a single composite team. The robots were not following humans at a distance. They were integrated into the unit structure, assigned roles, and executing them in parallel with their human counterparts. Analysts observing the footage noted that this level of real-world integration, demonstrated in a genuine field exercise rather than a controlled demonstration environment, represents operational maturity rather than experimental technology. The tireless nature of robotic companions changes the attrition equation in sustained operations. Human soldiers require rest cycles, nutrition, medical attention, and psychological recovery. A robotic companion carries its load continuously, transmits intelligence without fatigue, and does not degrade under extended operational tempo. For extended operations in challenging terrain that characterize the border and mountain scenarios China trains for specifically, that difference is operationally significant. While Western robotics companies debate when humanoid robots will reach commercial viability, Shanghai-based Agabot had produced over 960 humanoid robots by late 2024, with a target of surpassing 1,000 units by year-end. These are not demonstration models. They are deployed in manufacturing facilities, hospitals, and customer service environments. Footage from Agabot's production facilities shows human workers assembling robots alongside robotic arms, and completed humanoid robots already performing inventory management tasks in the same facility where they were built. The GR1 humanoid robot, presented at the World Artificial Intelligence Conference in Shanghai by Fourier Intelligence, moves on 2 legs at 5 kilometers per hour and carries a payload of up to 50 kilograms. Development began in 2019. By 2022, the robot could stand and walk. By 2024, it was entering mass production with explicit military application as part of the planned deployment scope. The cost remains high, millions of yuan per unit currently, but the manufacturing trajectory in China follows the same cost reduction curve that brought electric vehicles and solar panels from premium to commodity pricing in under a decade. China's specific competitive advantage in humanoid robotics is not hardware sophistication in isolation. It is the combination of scale, deployment speed, and integration into real operational environments. Where Western humanoid programs are still running laboratory tests, Chinese programs are running production lines. In September 2024, over 10,000 drones flew in perfect synchronization above Shenzhen, forming complex geometric patterns and moving as a single coordinated organism. The public saw an extraordinary light show. Military observers saw something else entirely. A live demonstration of the communication infrastructure and coordination algorithms required to manage 10,000 autonomous units simultaneously in real time. China has built a 5G network capable of connecting up to 10,000 drones simultaneously with ultra-low latency. That is not a network built for entertainment. The same architecture that coordinated the Shenzhen display can coordinate 10,000 scout drones feeding real-time intelligence into a centralized AI system, providing operational commanders with simultaneous multi-point battlefield awareness at a scale no human intelligence network can replicate. The swarm behaves as a digital organism, adaptive, self-coordinating, and capable of reconfiguring in response to conditions without waiting for individual commands from a central operator. U.S. defense experts watching this footage described it as a field test in disguise. The nation that masters swarm coordination at this scale gains an intelligence and targeting advantage that conventional forces have no existing doctrine to counter effectively. The Flying Drone Carrier Runtime. In May 2025, China unveiled the Guten, a massive unmanned flying drone carrier with a 25-meter wingspan and a 16-ton takeoff weight. This is not a large drone. It is an autonomous airborne hub designed to carry, launch, and coordinate swarms of smaller drones from altitude. Concept visuals show the Guten opening bay doors to release waves of coordinated smaller platforms, each assigned a specific role in the mission, moving in unison, operating as a distributed system launched from a single mother platform. One Guten could deploy hundreds of autonomous drones in a single mission, operating in contested airspace where conventional aircraft face unacceptable attrition risk. The smaller drones handle surveillance, communication relay, and targeted tasks while the Guten coordinates from altitude. The size of the platform makes it more visible to radar than stealth aircraft, but the operational logic is not stealth. It is scale and coordination. A single platform that can fill an operational area with hundreds of autonomous systems creates a coverage and persistence advantage that no conventional air power deployment achieves at comparable cost or risk to personnel. The Guten represents the top layer of a system of systems that extends from the mechanical yak on mountain terrain at the bottom, through rifle-mounted quadrupeds and robotic companions in the middle, to autonomous drone swarms and flying carriers at the top. Each layer reinforces the others. Together, they form the architecture of an unmanned force designed to operate coherently across land, sea, air, and the space between them. A 160-kilogram logistics robot built for terrain no vehicle can navigate. Armed quadrupeds deployed by drone onto rooftops behind enemy lines. 10,000 drones coordinated simultaneously through a 5G network. A flying carrier that launches autonomous swarms from altitude. Humanoid robots entering mass production with military deployment as a stated objective. China is not building one impressive autonomous system. It is building a layered, integrated, autonomous force, and it is building it faster than anyone else. Drop a comment telling us which capability you think changes the strategic picture the most. Check the end screen for more defense and technology breakdowns sitting there waiting.